Hello my dear friends, welcome back to your channel of learning mathematics. So if you remember in that previous exercise of chapter 7 we have learned about congruency, how triangles can be congruent, what are the criteria for which the triangles can be congruent, and of course yes, what is the meaning of congruency. That means the triangles are exactly the same. And the criteria were side, 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 angle, angle, side, angle. Those were the criteria if you remember. So now in the next exercise, we will not be needing a lot of the concepts. We'll be just learning two more new basic concepts. Plus, yes, of course, the concept of congruency will be carried forward. Okay. So here what we are going to learn today is we will be learning two more theorems. All right, so the first theorem that we will be learning, see, you remember theorems are what? These are like something like formulas that we have in algebra. Okay, so this will be like tools that will be given to you to help you solve your geometry problems. So the first theorem that we will have here today here is, we will not be going for the proof here. It says like angles opposite to equal sides. I hope you brought your pen, paper and copy. And isosceles triangle. Angles opposite to equal sides of an isosceles triangle are equal. So here the concept is very simple. Suppose you have a triangle, an isosceles triangle in which any of the two sides are same. So let us assume that the two sides AB and AC are same. AB and AC are same. So what it states is that the angles opposite to the equal sides. What are the angles opposite to equal sides? What is the angle opposite to AB? C, isn't it? And the angle opposite to AC? B. So these two angles also will be equal. That is, angle C will be equal to angle B. So it says that the angles opposite to equal sides of an isosceles triangle also are equal. So you have a triangle in which two sides, opposite sides are equal, then their opposite angles are also equal. Then the second one is just the vice versa, converse of this particular theorem that states the sides opposite to equal angles. The sides opposite to equal angles of a triangle are equal. The sides opposite to equal angles of a triangle are equal. So again, something like you have a triangle ABC. So this time what they say is that the sides opposite to equal angles, let's say these two angles are equal. So then if two angles are equal, opposite angles are equal, then they're opposite. If two angles are equal, then the sides opposite to the angles. What is the side opposite to angle B? That is AC. And side opposite to angle C, that is AB. So here what they state is that in a triangle, if you have two angles which are equal, then their sides opposite to them are also equal. Alright, so basically these two concepts will be required, plus concept of perpendicular bisector and angular bisector. Suppose you have an angle, these are already known, but let me just give you. Suppose you have an angle AOB. Okay, and maybe there is a line, there is a ray which is bisecting. When we say bisecting, bisecting. So suppose let's say this is C. So OC, if it says that OC is bisecting angle AOB, in that case it means that this ray is actually cutting the angle into two equal halves, this angle and this angle. That means this angle and this angle are equal angles. All right, bisection. Similarly, perpendicular bisector means on a line, suppose let's say AB in a line segment, suppose there is a perpendicular bisector. See, these terms are very important. Okay, perpendicular bisector. Now perpendicular bisector means there is a line perpendicular to the line AB making 90 degree. So when we say perpendicular bisector, it means that suppose the point where it touches the line AB is at point C. That means this point C also acts as the midpoint. midpoint of AB. That means AC also will be equal to BC. So these are the terms that we will be coming across. So when we do those questions, let's not waste time discussing about that. All right, that's why I gave it to you. Okay. All right, then let's move on to the exercise. The first question, which says exercise 7.2. Okay, so this is the first question that states, in an isosceles triangle ABC, with AB is equal to AC, the bisectors of angle B, bisectors, remember, no, bisector, that means suppose this is a bisector, so these two angles are equal, okay, and the bisectors of angle C, that means again these two angles are equal, intersect each other at O. Show that OB is equal to OC. Show that OB is equal to OC, and AO bisects angle A. That means these two angles are also equal. That means this AO is cutting the angle A. This angle is by cutting the angle A into two equal halves. That's what we will be proving. All right. So what happens here is that these are bisectors. So these two angles are equal and these two angles are also equal. So let's go for the proof directly. Okay, let's go for the proof directly. Given AB is equal to AC. All right, that's given. So if AB is equal to AC, that first theorem that we learned today, if AB is equal to AC, then their opposite angles are also equal. So in that case, angle A is AB. Nah? So what is the opposite angle to AB? This angle, full angle, C. So angle ACB is equal to AC, opposite angle is this angle ABC. Angle ABC. Reason, of course, if you wish, you can write down that same reason. What was that reason? That is angles opposite to equal sides are equal. So now I'll divide both sides by half, by 2. So I'm mentioning that, so in that case it becomes half of AC and half of ACB and half of ABC. Now you see OB bisects angle ABC and OC, this is for your understanding only, bisects angle ACB. That means these two angles are equal and these two angles are equal. So that means I can, half of angle ABC means either this one or this one, because both the angles are same. Half of angle ACB means either this one or this one, because both the angles are same. So I'll focus on this interior triangle only. So I'll say that half of ACB can also be written as this one, angle OBCB. Angle OCB is equal to half of ABC. Half of ABC, either you can write OBC or you can write OBA, but this one we don't need, we will use this OBC. So OCB is equal to OBC. That means in this triangle, therefore in triangle BOC, what happens is angle OCB is equal to angle OBC. So in that case, if I just try to draw that smaller triangle, what are we getting? We're getting that OB is equal to OC. So if two sides are equal, then their opposite angles, of course, opposite angles also become equal. I mean, if two angles are equal, then their opposite sides become equal. Sorry. So in that case, so OB equal to OC. Reason? Just the second one, that is sides opposite to equal angles are equal. Proof. Second one, AO bisects angle A. So what I'll try to do here is I'll try to prove that these two triangles are congruent. Very simple. In triangle OAB and triangle OAC, these two triangles, you can see OA already common. OA is equal to OA. Reason? Common side. Already given AB is equal to AC. given. We have already done congruency, na? And OB is equal to OC. This is already proved. So therefore, by side congruency criteria, triangle OAB is congruent to triangle OAC. So in that case, what will happen? In that case, the remaining angles are all going to be, corresponding angles are all going to be equal, but we need this one only. If we can prove that these two angles are equal, what does it mean? These two angles are equal, that means half, same, na? So that means this is of course the bisector. So therefore angle OAB is equal to OAC. Reason? Corresponding parts of congruent triangles. Bus. So therefore AO bisects angle A. Alright, that's it. Simple as that. Okay, done. You can pause the video here and note down. Alright, I'll move on to the next question. Okay, question number 2. That is, in triangle ABC, AD is the perpendicular bisector. Remember, no? Perpendicular bisector of BC. That means these two sides. This BD is equal to DC. That means D acts as the midpoint. So that, let us write on that first quickly. Na? Given AD is the perpendicular bisector of BC, so BD is equal to DC. Alright, that is given. And triangle ABC is, show that triangle ABC is an isosceles triangle in which AB is equal to AC. Isosceles means two sides are equal. It's very simple. Perpendicular means, perpendicular bisector means, I'll write this one, that is ADB is also equal to ADC is also equal to 90. That means this angle and this angle both 90, na? Because this is perpendicular. Alright, so very simple proof. In triangle ADB and triangle ADC, AD is equal to AD, common side. Let's do this quickly. BD equal to DC, that's actually, since we have already explained, given. And angle ADB is equal to angle ADC, 90 degree each. So therefore triangle ADB is congruent to triangle ADC by side angle side. So in that case, ho gaya, because these two triangles are congruent, this equal to this, this equal to this, this equal 90, 90. So the other parts will be equal, that is AB is equal to AC, corresponding parts of congruent triangles. So triangle ABC is an isosceles triangle in which AB is equal to AC. Simple proof. Ho gaya? Chalo, you can pause the video there and note it down. Alright, done? Chalo. Let's move to the next question, third one. ABC is an isosceles triangle again in which altitudes BE, altitude means B, altitude means again what? Altitude means perpendicular, okay, altitude means perpendicular. Alright, so this is 90, this is also 90, it stands on AC. And CF, they are also perpendicular, so from here we draw this line perpendicular, so 90, 90. Are drawn to equal sides, AC and AB respectively. So given AC equal to AB, nah? That's what they have given. Show that these altitudes are equal. To show what are the altitudes, BE and CF, they are equal. Alright, let's go for the proof then. Chalo, very simple proof. Okay, what can be done here is, okay, let me just write down, it's okay, na? Since BE and CF are altitudes on AC and AB respectively, angle AEB, is equal to angle AFC is equal to 90 degree. Even like BFC also and BEC also 90. This side also 90, this side also 90. Now perpendicular means both sides 90, 90 each. Alright, but I need these two angles only, so I'm just writing this one. The rest of the things, nothing much given. So what we can do is, I'll have to prove that BE is equal to CF. So if you can look, there is a common triangle that we can find. That is in triangle AEB and triangle AFC. Let's try to cut it out. Okay, cutting it out always helps, like this. So this triangle AEB. I've tried to cut out. That is AEB 90, and the other one is like this. That is CFA. Now this triangle, and again this triangle. Right. What can we have? Already given. That is angle AEB is equal to angle AFC 90 degree each. AB equal to AC. AB equal to AC. That is already given. So you can see that we have to prove that BF equal to CF. If I can prove that these two triangles are congruent, then kaam khatam. Then now you can see that in these two triangles, this triangle and this triangle, what is common? You can see that angle A comes for both, isn't it? Angle A equal to angle A. Visualization common. So therefore triangle AEB is congruent to triangle AFC by angle side congruency criteria. So in that case, simple, because these two triangles are congruent, so corresponding sides BF equal to FC. That is congruent parts of congruent, corresponding parts of congruent triangles. So therefore these altitudes are equal. Oh yeah, bus, that's it. Alright, so simple proofs depends on how strong your concept is. Alright, so if you've liked this video, please give me a like. Okay, and alright, then do subscribe and share. I'll see you in the next video with the next set of questions. Bye bye, take care.